Okay, so I was saying that if it is correct for P of 1, it means it will be correct for one integer, that is the consecutive, the next integer, it will be correct for P of 2. If it is correct for P of 2, it should be correct for P of 3. If it is correct for P of 3, it should be correct for P of 4. And likewise, we can keep on moving forward up to thousand, lakh, or like whatever million, whatever value you want. For all the integers, it is proved to be right in only 3 steps. So this is the crux. This is how the mathematical induction works. Okay, so let us now try another question and see if we are able to do that question or not. Now, this question is again a very similar question. Now, the preposition is 6 raised to power n minus 1 is divisible by 5. It means that it should be equal to 5 into x. So I'm just assuming x, any random number. And if it is 5x, it is divisible by 5. So first of all, let us prove it for p of 1. And let me write step number 1. So P of 1, let us try. 6 raised to power 1 minus 1. Yes, it is coming out to be equal to 5. It is divisible by 5. So it is proved. So we will say P of 1 is true. Step 1 is over. So now we are moving to step number 2. And step number 2 is we go for n is equal to k and we substitute this. So 6 raised to power k minus 1 is equal to 5x. We are going to assume this thing now. So this is the assumption. We have just assumed it because we don't know what is the value of k. It could be any, it could be right, it could be wrong, but we have assumed it, that let us say it is right. So now we move to step number 3, that is p of k plus 1. So what am I getting here? Now this thing, I can't write this equal to 5x because I don't know whether it is divisible by 5 or not. So what we do is we just try to break this thing. 6 into 6 raised to power k minus 1. And likewise, we have done in the earlier example, we found the value of 6k from this, which can be substituted as 5x plus 1. I substituted here. Now, I am just going to simplify. 5 6 are 30 plus 6 minus 1. So 30x plus 5, and absolutely correct, we have now taken 5 as common, so we are left with 6x plus 1. And there we are. You see, is this number divisible by 5? Absolutely correct. Whatever be the value of x there, whatever rational, irrational, root 2 or root 3 or whatever, even then this 5 is going to be there. So I can say that yes, p of k plus 1 is divisible by 5. So I will say, so p of k plus 1 is divisible by 5 if, now there is this condition, if p of k is true. If p of k is true, then under this condition I can say that p of k plus 1 is true. And we have already proved that p of 1 is right. It only means that p of 2 is right. And if p of 2 is right, it only means that p of 3 is right. So likewise, it will be true for all the upcoming consecutive positive integers. So this is how we do it, and that is what the statement that we are going to write over here, that because p of 1 is true, the preposition is true for all the upcoming positive integers. So this is another example that I have taken for mathematical induction. Let us see a couple of more questions in the upcoming video. Till then,